Hello everyone, this is Dennis, and you're on the Den Electro channel. Today I'll be reviewing this unusual gadget. This is a step-down voltage converter. It has two USB ports that support fast charging, making it suitable for making homemade phone chargers or power banks. The module's design is simple, and it doesn't have many parts. Capacitors, inductors, 4 microcircuits, and an LED. Power from 12 to 30 volts is supplied here. The positive and negative terminals are labeled. The heart of the module is 2 microcircuits, NS6316 and NS6312. This is roughly what their schematics look like, as found in their datasheets. This is a step-down DC-DC converter with fast charging. Thanks to the second microcircuit, the converter's output voltage can be varied using the Quick Charge 2 and Quick Charge 3 protocols, resulting in output voltages of 5, 9, and 12 volts. As you've already noticed, the port colors are different. This is not a coincidence. Their output characteristics also differ, and we'll see this later in the tests. The first port is powered by a weak NS6312 microchip. It can deliver 2 amps. And the second port, with a more powerful NS6316 microchip, delivers 3 amps. The other specifications of the microchips are identical. The datasheet states that they can operate with an input voltage of 4 to 30 volts, and the output can be from 1.8 to 28 volts. But this module, of course, won't handle such high voltages. That's for the output. But the input can handle a full 30 volts. The input of each microchip has 35-volt capacitors. Although, of course, it's best not to use the microchips at their maximum limits. I would recommend applying a maximum of 28 or 27 volts to the input to allow for some headroom. The capacitor in parallel with the second port's output is only 10 volts, so there won't be much voltage there. However, the capacitors in parallel with the second port's output are higher voltage, 16 volts. A higher voltage is expected there. Without a load, the module's output voltage at the first port is 5.2 volts. And at the second, 5.1 volts. This is a normal voltage for any USB gadget. When operating at 12 volts, this module draws 3.6 milliamps. And when operating at 25 volts, 2 milliamps. Most likely, the LED draws most of the power from this board. But even if it's disconnected, I think the board will still draw some current. And it's best not to leave it connected to batteries. Now let's see how this module charges a phone. This multimeter shows the input voltage. I'm currently supplying 24 volts to the module's input. I've inserted a USB tester into the first port of the module, and I'll be connecting the phone to the tester's output. The tester's display will show the voltage from the module and the current consumed by the load. Please note that my USB tester is slightly modified. I added a button to the display backlight. When I press it, the display turns on, and when I release it, it goes out. So don't pay attention to that. Currently, the output voltage of the first port is 5.25 volts. I connect the phone, and the current it draws increases. But for now, it's fluctuating between higher and lower. The phone is trying to figure out what it can get out of this module. Ultimately, the voltage settled at 5.3 volts, and the current draw is 1.93 volts. Now I'll try reducing the input voltage to 12 volts. As you can see, the input voltage has dropped, but nothing has changed at the module's output. That's very good. I'll increase the voltage again and move the USB tester to the lower port. The voltage here is 5.14 volts. I'm connecting the phone. The current starts jumping again. And then the 5-volt module increases the voltage to 9. At this voltage, my phone draws about 1.6 amps. I'll try reducing the voltage again to 12 volts. The module's output, just like last time, remains unchanged. So the module will work fine from a 12-volt lead-acid battery and from 5 lithium-ion batteries, which have a total voltage of 21 volts. Now I'll try reconnecting the phone and see if the current drawn by the phone is the same when powered directly by 12 volts. Yes, everything is fine. The module switches to 9 volts and 1.5 amps of current. This means the left port can only output 5 volts and 2 amps, while the right port can only output 9 volts and 1.6 amps. But perhaps this port can also output 12 volts. I just don't have anything to test it with right now, since my phone doesn't support that voltage. This step-down DC-DC converter comes with a case. It consists of 3 covers and 4 screws. The module's board fits into this half and is covered from below by one of these plates. At first glance, they look identical, but they are different. The one on the left has walls around the screw holes that protrude above the surface of the cover, while the one on the right doesn't. If I insert the left cover into the case, its protruding posts press it firmly against the board, but it starts to protrude slightly from the case, since it isn't inserted all the way. It protrudes literally 0.3 millimeters, and it's barely noticeable. But the second cover fits deep into the case and doesn't protrude beyond its edges. But it doesn't press down on the board inside the case. And so, perhaps, when you connect some gadgets, the board will move around inside. So I still don't understand why they had to make 2 different covers. They could have made one that would fit snugly and wouldn't move. If you have any thoughts on this, let me know in the comments. That's all for today. Like and subscribe to my channel if you haven't already. Click the bell icon to stay up to date with new videos. Ask questions in the comments if anything is unclear. And bye, everyone.